Kirchhoff laws. There are two laws. Number one law is Kirchhoff's current law. Kirchhoff's current law. Under bracket we can write down the alternative name of Kirchhoff's current law, that is junction law, because Kirchhoff's current law is applicable for a junction of a number of wires. So now the Kirchhoff's current law states that the algebraic sum of currents meeting at a junction in a closed circuit is 0. The algebraic sum of currents meeting at a junction in a closed circuit is 0. In a closed circuit is 0. Now we can draw a diagram. That means we can draw a junction of 5 wires. We assume that there are 5 wires which are meeting at a junction O. So we can draw 5 wires, 5 conducting wires through which currents are flowing. So these are the 5 conducting wires through which different currents are flowing with respect to the junction O. With respect to the junction O, O is the junction of 5 conducting wires through which different currents are flowing. I1 is the current which is flowing through the first conducting wire and which is flowing towards the junction O. Similarly, another current I2 is flowing towards the junction O, but the third current I3 is flowing away from the junction O. Fourth current which is flowing through the conducting wire towards the junction O, and the fifth current I5 is flowing through the fifth conducting wire, and this current I5 is flowing away with respect to the junction O. Using Kirchhoff's current law, that is KCL, at the junction O of 5 wires, using KCL or Kirchhoff's current law at the junction O, we get summation of I equal 0. That means algebraic sum of currents meeting at the junction O in a closed circuit is 0. Summation of I is equal to 0. Therefore, with respect to this case or this diagram, we can write I1 plus I2 minus I3 plus I4 minus I5 is equal 0. I1 plus I2 minus I3 plus I4 minus I5 equal 0. In the diagram, I3 and I5, the currents I3 and I5 are flowing away from the junction. I5 is flowing away from the junction, and other currents I1, I2 and I4. These 3 currents I1, I2 and I4 are flowing towards the junction. That's why these currents I1, I2 and I4 are taken as positive, and the currents I3 and I5 are flowing away from the junction O. That's why they are taken as negative. Additional information in connection with Kirchhoff's current law. KCL supports the law of conservation of charge. KCL supports the law of conservation of charge because KCL supports the law of conservation of charge because a point in a circuit can not act as a source or sink of charge. A point or junction in a circuit cannot act as a source or sink of charge. According to Kirchhoff's current law, that is using KCL for the junction O of 5 wires, we get summation of I equals 0. Therefore, I1 plus I2 minus I3 plus I4 minus I5 is 0. Or I1 plus I2 plus I4 equal I3 plus I5, that is sum of currents flowing towards the junction O, is equal to the sum of currents flowing away from the junction O. Multiplying all the terms or multiplying equation 1 by dt, where dt is small interval of time, multiplying equation 1 by dt, where dt is small interval of time, we get I1 dt plus I2 dt plus I4 dt is equal I3 dt plus I5 dt. Sum of product of current and a small interval of time, and integrating both sides, integrating the above equation both sides, we get integration I1 dt plus integration I2 dt plus integration I4 dt is equal to integration I3 dt plus integration I5 dt. Or comma q1 plus q2 plus q4 equal q3 plus q5. q1 plus q2 plus q4 is equal q3 plus q5. Here the current I is dq by dt, that is rate of flow of charge, therefore dq equal I dt, therefore integration dq equal integration I dt, therefore the charge q is equal integration I dt. That means charge is equal to the integration of current over small interval of time. Therefore the amount of charge under bracket q1 plus q2 plus q4 which is flowing towards the junction O, the amount of charge under bracket q1 plus q2 plus q4 which is flowing towards the junction O should be equal to the total amount of charge, should be equal to the total amount of charge under bracket q3 plus q5 which is flowing away from the junction O, which is flowing away from the junction O, the total amount of charge which is flowing towards the junction O should be equal to the total amount of charge which is flowing away from the junction O. Hence, no charge is created or destroyed. No charge is created or destroyed at the junction O. At the junction O. And the junction O does not act as a source of charge or sink of charge. The junction O does not behave as a source of charge or sink of charge. Therefore, Kirchhoff's current law supports the law of conservation of charge. Kirchhoff's current law supports the law of conservation of charge. Kirchhoff's current law supports the law of conservation of charge. Kirchhoff's voltage law. Now we have to state Kirchhoff's voltage law. Alternative name of this law is loop law because Kirchhoff's voltage law is applicable for a closed loop in an electric circuit. Kirchhoff's voltage law is what? The algebraic sum of potential difference. The algebraic sum of all the potential differences. In any closed path or loop. The algebraic sum of all the potential differences in any closed path or loop of an electric circuit is zero. Now we can explain Kirchhoff's voltage law or loop law. For that we can draw a closed loop. This is a battery of EMF E to which two electric resistances or two electric resistors of resistances R1 and R2 are connected to form a closed loop. R1 and R2 are the resistances of two electric resistors which are connected to a battery of EMF E. These are the positive and negative pole of the battery. R is the internal resistance of the battery. A current I is generated from the positive pole of the battery, and that current I will be flowing through the resistances R1 and R2. and current I flows from negative pole to positive pole inside the cell through the internal resistance. V1 is the potential difference across the external resistance R1. V2 is the potential difference across the external resistance R2. We can give the name of the loop, that is ABCDA is the closed loop in the same direction of current. Using Kirchhoff's voltage law, that is KVL, in the closed loop. In the closed loop ABCDA, we get summation of V equals 0. That means sum of all the potential differences in the closed path is 0. We travel in this direction, that is, we are considering the loop ABCDA. For that, there are four potential differences, that is V1, V2, E and I dot R, and that will be equal to 0. In this case, V1 is positive, V2 is positive, EMF E is negative, and I dot R is positive. We have R1 and R2 as external resistance and a battery of EMF E existing in the loop. We are traveling from A to B and also traveling from B to C, and current I is also flowing in the same direction. That's why potential differences across R1 and R2 will be positive. That means plus V1 plus V2. Current I is flowing towards right, and we are also traveling from B to C to cross the resistance R1 and R2. That's why V1 and V2, that means potential differences across the external resistances R1 and R2 will be positive, because we are traveling from B to C and current I is also flowing in the same direction. Now we have to move from the point D to A, and in this case we have to move from D to A, and while crossing the battery of EMF E, we have to cross the first negative pole of the battery, then positive pole of the battery. That's why EMF of the battery will be negative. That means E tends to minus E. E tends to minus E. Also Kirchhoff's voltage law. Kirchhoff's voltage law supports the law of conservation of energy. The law of conservation of energy, because if a charge is taken through the closed loop, work done will be 0. Kirchhoff's voltage law supports the law of conservation of energy, because if a charge completes a closed path or complete loop, if a charge completes in a closed path, the net change in energy of the charge must be 0. The net change in energy of the charge must be 0. That's why Kirchhoff's voltage law supports law of conservation of energy. Net change in energy of the charge must be 0.